What we're looking at here is a piece of test equipment referred to as an insulation continuity tester, otherwise known as a megger. This particular instrument is manufactured by A.W. Sperry. The word megger is actually a trade name with a different company. So you may hear electricians in the field refer to instruments as meggers even though they don't bear that name anywhere on the label. What this does is it functions as a specialized ohmmeter. This particular model has two sets of ranges. One is for low resistance continuity checking, and the other one is for high resistance, high voltage insulation testing. This is where, in the high range setting, this meter really plays a unique role. In the low range setting, it's not much different from a regular ohmmeter. In fact, a garden variety multimeter do just a fine job with continuity and low resistance checking. It's in the high voltage, high resistance checking area that this meter plays a unique or special role. And the way it works is when you move the selector switch on this instrument to various positions, it selects different amounts of voltage it will output in performing its resistance test. You'll notice these are fairly high voltage ratings, 250 volts, 500 volts, 1000 volts. These are much, much higher voltages than your average ohmmeter would use in testing the resistance of a circuit. And we use this for testing the insulation of devices such as the electric motors to make sure the integrity of the insulation is good and that we don't have any breakdown of the electrical insulation between a conductor and ground. When we look at the test leads for this particular instrument, we see one, the big clip on it, that typically goes to the frame of the device, such as the electric motor you'll be testing, and then this has a sharp probe at the end. This is used to make contact with the conductor that you want to test the insulation of. So the notion being you take the ground clip, go to the frame of the device, take this, touch the conductor, and then with one of the high voltage settings, you're going to measure resistance between that conductor and the chassis ground of the device. Now, if the insulation is in good shape and we don't have any breakdown of the insulation at all, you should measure a very high resistance. The needle should stay on the high mega ohm end of the scale. On the other hand, if there's a breakdown or a ground fault of the insulation, you'll see the needle swing towards the right-hand side of the scale, possibly all the way to 0 if it's a hard fault to ground. So you need to be aware of this instrument when you use it. It uses a fairly high amount of voltage to do the testing, and yes, this will shock you if you use it incorrectly. This particular model is battery powered, and what you do is you activate the high voltage by pushing the test button. On some of the older devices, especially the ones bearing the name megger, they used to have a hand crank on the side. You would turn a hand crank and it would spin a high voltage DC generator that would generate the power necessary for doing the test. Personally, I prefer the hand crank style because that has a built-in safety feature. You can't shock yourself as you're cranking the hand crank. You'll automatically stop. In this case, it is possible to latch the button in the on position and have it continually produce high voltage. So you need to be very careful with an instrument like this when you're using it. You also need to be careful for a couple of other reasons. If you're using a megger like this, or an insulation tester, and you're using it on a voltage setting that is much higher than the voltage rating of the device that you're testing, it may be possible to actually damage the insulation of that device. So you need to be aware of its limitations in that regard. Also, you must never, ever use a high voltage setting on an instrument like this to test a semiconductor device, such as a variable frequency motor drive. I have seen electricians destroy VFDs by connecting the output of a megger to one of the terminals, T1, T2, or T3 on the variable frequency drive, and then applying high voltage with the drive off. What they were trying to do is test the motor that the drive was connected to, but in applying this high voltage between one of the motor terminals and ground, they were simultaneously applying a very high voltage to the switching transistors of the variable frequency drive. So again, to illustrate you, showing you a real drive, something like this Allen Bradley model, that's generating variable frequency to an induction motor. If you were to connect an instrument like that insulation tester we just saw between any one of the motor terminals and ground with the motor connected, expecting to test the motor, you're also going to be subjecting the switching transistors in this drive to very high voltages, and that will likely destroy the drive. So be aware of that, be aware of the limitations of the device, its inherent safety hazards, and know that in some cases you can actually destroy equipment it's connected to.